Hello, welcome to Tech Talk with Steve, episode 53, Ensuring Shield Integrity in Field Testing. My name's Steve Cowles, your host. I am the Product Manager and Technical Services Manager for AEM Precision Cable Test. And as the title indicates, today we're going to be talking about shielded cabling and how to make sure that the shield is actually in good shape. So you might assume that just because you hook up and you see a wire map and it shows a good shield on there, yeah, everything's good, but we're going to dive into that a little more. We're going to talk about, different types of shielded cabling. We're going to talk about the importance of shielding, and then we'll be running some tests to kind of go into this and show everybody what it is we're talking about when we talk about a shield integrity test. So one thing I would like to do, we've had some questions that have come in ahead of time, and question number 2, Jacqueline, if you could bring up question number 2 for me. What is the benefit of using shielded twisted pair cabling? So we'll start with that one. So the big benefit of shielded twisted pair cabling is that it helps to keep noise out. So you help to keep noise from ingressing into the cabling and causing problems with your data transmission. But it also helps to keep noise from getting out of the cable. And you might think, well, what are we talking about with noise getting out of the cable? So there's something called alien crosstalk that means that you're getting signal from one cable bleeding over into another cable. We all in this industry are familiar with crosstalk between pairs. And if we go way back to, I call it the olden days, we talk about using a landline telephone and hearing somebody else's conversation. That's crosstalk. That conversation you're hearing bleeding over from another pair is crosstalk in its very basic format. That's why it's called crosstalk, because you could hear the talk from another line bleeding into your line. And it's annoying when you're on a phone call, but for data transmission, especially high-speed data transmission, when we start getting up into the multi-gigabit speeds, it becomes a big problem. And that's one of the certification tests that we do. And our qualification plus tester, the network service assistant, also does crosstalk testing. So crosstalk's one of the big tests that we do when we're certifying or otherwise testing the cables to make sure that they're ready and they're going to support what you're going to be running over them. So by adding that shield, you decrease the chances of noise getting in or noise getting out. Now, even basic unshielded cabling, unshielded twisted pair, especially once you get up to Cat 6A, is designed to mitigate that. Cat 6A was specifically designed to mitigate the effects of crosstalk and alien crosstalk, especially. So even in unshielded cables, you've got the construction that is designed to keep that noise at a minimum. Shielding is another way of mitigating the noise, and you can get it in a variety of categories of cables. Shielded cables been around for a long time. Even your outside plant phone cables, if you still have a landline, the stuff that the phone company installs has shielding built into it as well. I'm going to go ahead and I'm going to share my screen here, and I'm going to bring up a slide here. And this is going to be the only slide that we've got today. The rest of this will be more live action. I wanted to kind of go over some twisted pair cables, and I pulled this off of the Universal Networks website to talk about UTP versus shielded cabling, so that we can have a baseline. And there's various types of cabling here. So we go down through the list. UTP is here in the U.S. This is the most common, unshielded. There is shielded being installed in the U.S., but UTP is more common. And if we take a close look at the cable itself, you'll see there is no shielding on that cable. There's an outer PVC jacket, and then you've got your 4 twisted pairs. We get down to the next one. The ISO name, FUTP, is if we look here, the cable shielding type is a foil. So that's the outer shield. And then the twisted pair shielding, there is no shielding on the twisted pairs. So if we take a zoom in look at that, we see that, yes, there's just a foil overall, and each of the individual pairs does not have a shield. So it's like just putting a foil wrap between the jacket and those unshielded twisted pairs. Now, when we're looking at these designations under this ISO column, that first designator in here, when we're looking at UUTP, which we commonly call UTP here in the US and other places, the first U here, the letter designation before the slash, indicates the overall cable shielding. And then the letters after the slash is what indicates the type of shielding around the pairs. So that's why you see those with these designations with a slash in them. So then you've got that FUTP we just talked about. The next one is SUTP. So what's different between SUTP and FUTP is the type of overall shield. It's a braided shield on an SFTP, as we can see here. It's same construction, but that shield now, instead of being foil like we had in this first one, is a braid right here in this second one. And as we continue on down the list, the next one, an SFUTP. And as you'd expect, it's got an S and an F, so that overall is going to be braiding and foil. And if we zoom in on that, we can see that as well. We see a braid and a foil overall, and then those unshielded pairs. The next one down is a UFTP. So that means no overall shielding, but the individual pairs, as you see here, have a shield. We move on down to FFTP. This has got a foil shield and then foil around each pair. And then an SFTP is going to have that braided shield and then foil around each pair. And you'll notice there's a drain wire here. That's so you can bond it. And then our very last one here, the SFTP, has a foil. Underneath that, has a braid overall. And underneath that braid is a foil. And then underneath that, each of the pairs has an individual shield. That last one is the most heavily shielded in the examples here and provides the best protection against noise of all of these cables. Each of them has a different level of noise protection. And the reason I wanted to show you these various types of shielded cables is when we're talking about shield integrity, what we're really looking at is not just that our shield is continuous from end to end, but the properties of the shield need to be the same from end to end whenever possible to mitigate any issues. Mixing different shielding types in the same cable plant can sometimes actually inhibit our noise mitigation. So we want to make sure that where at all possible, these types of shielded cablings are compatible. And sometimes that's not always possible when we look at patch cords versus the installed cabling. Sometimes you can't always match that up. But it is good to be able to detect those differences, because if you do run a test, say for instance with our multi-gigabit Ethernet test capability, or even the 1 gig SNR test capability, where you're running a test, say at 2.5 gig, and you see bad signal to noise ratio levels, you've got excessive noise, it'd be good to run a physical cable test on that shielded cabling, if you do have shielded cabling in that instance, and see, do I have any anomalies in my shield? Are there any problems along the shield where that shield is discontinuous, or it has different properties? It changes properties along the shield. So it's always good to be able to look at that. So I'm going to go ahead and escape out of this presentation here. And then I've got in front of me here, we've got our, right here on the camera is my TestPro remote. I've got my TestPro main right over here, and I'm projecting that onto the left side of the display here so we can see both ends during this test. And we'll go ahead and run a couple tests here. So one thing I would like to do, Jacqueline, if you can bring up question number 1 that we got that came in ahead of time. That is, when installing shielded twisted pair cabling, do I need to ground it at both ends? So this is a very, very good question. And it's kind of a yes and no answer. In reality, if you have a shielded cable in use and it is only grounded at one end, it actually becomes an antenna and draws noise in. So the way you ground that, though, is not actually during the installation on both ends. When you're doing the install at the patch panel end, it's going to be bonded. So your shield has to be, the cable has to be terminated with shielded connectors first off. And at the patch panel end, that shield is part of the grounding system in the patch panel, and that panel gets bonded to the grounding system. So at that end, it is grounded. It's bonded to the grounding system. On the telecommunications outlet end, or the wall plate end, if you will, or even in an MPTL situation where you're putting a field terminated plug on the end of that twisted pair cabling, and it's going to plug into a device. When you have equipment at the far end, that's where your grounding happens. So when you install that telecommunications outlet, that faceplate, you don't have to bond that connector in the telecommunications outlet to the building ground system right there. You don't have to take it to a ground lug or a ground bus. Where the grounding happens is when you hook up your equipment, your PC or a server, whatever it is you're going to connect, switch or router, a work group hub. Those devices have built-in grounding through their electrical connection, and you should use a shielded cable to go from the telecommunications outlet shielded jack to the equipment, which has a shielded jack built in. That is where the grounding takes place. That is the grounding at the remote end. So that's how you ground. You don't ground at the telecommunications outlet itself. It's grounded through a shielded patch cord. Now, this brings up something else. Make sure that if you have shielded cabling, that you're using shielded patch cords. Because if you're not, then your grounding system may not be complete. So what could happen if you don't use a shielded patch cord? If you don't use a shielded patch cord, you haven't grounded at that remote end, so now you created that antenna that I talked about. So that'll draw noise into the cabling system and cause issues. What happens if you did ground it at both ends in the install? So you've got that it bonded at the patch panel and you bonded it at the telecommunications outlet. And then you plug in a shielded patch cord going into your equipment. You've got a ground loop. You don't want to have a second path to ground. There's a lot of problems that can come in that. So you don't want to create a ground loop by bonding it at both ends. A ground loop will also act as an antenna. So when you bond it at both ends, it's going to act like an antenna. It acts differently when you're not bonded at the outlet and you're plugged in with a shielded cable into equipment. It doesn't become an antenna in that situation. It's not creating a ground loop. So hopefully that makes sense. I didn't want to try and get too technical on that. But Chuck Bowser even covered this on one of his episodes, I believe, as well. So, make sure you go over and tune in to Chuck at Let's Talk Cabling, Chuck Bowser, RCDD Tech. And he has his Let's Talk Cabling show every Thursday night at 6. He also just posted a YouTube video out there. We talked about cable certification tester calibration. So make sure you check that out. So let's talk a little bit more about this test. So I've got my tester set up here, as I mentioned. I'm going to go ahead and I've got a cable here that we're going to test. And I've got my remote over here. My main is over here. I'm going to plug into my main so we can run our test. And we immediately get a wire map at both ends. And I've got a connection here that's a little iffy there. All right, we're good. So I have a wire map on both ends. It's kind of hard to see on this remote just because of the camera doesn't like the brightness of the LCD, but we've got a wire map here. So you get an instant wire map, or what we call live wire map, on both ends as soon as you connect to the cabling. This is critical when you're out there in the field, because if you have a wire map problem, you want to know about it before you take the time to try and run a test. So we tell you about that right away. If there was an issue with the wire map, we could do a wire map diagnostic. So if there's a short or an open or whatever, it'll tell us how far that event is. So I'm going to go ahead and run an auto test, and I've already set this up. As you can see here, I'm using shielded cable. I've got it set up for a shielded test. And we see this passed. I can look at my wire map. Wire map looks good. I go to details, and I can see all my normal plots. If I want to look at crosstalk, I can go in and I can take a look at my crosstalk plot. I can go down and look at any of the details, really. Even up here at the top, we get network compliance. So in this case, this is good up to 5 gig, because I just ran a Cat 6 test on this cable. This is actually Cat 6 cable in here. Cat 6 or Cat 6A, it's still going to take 6 seconds, and it's still going to include your DC resistance, unbalance, and everything. So down here are some things that I wanted to show you. We've got RL locator, Next locator, and Shield locator. If you're doing UTP cabling, you're set up with your TestPro or your NSA, because both TestPro and NSA do these tests and have all these features. You will, if you're on UTP, you're not going to have the Shield locator. You'll have the RL locator to pinpoint where along your cable your return loss problem is, and your next locator will help you pinpoint where along the cable the crosstalk problem is. The shield locator, when you set it up using shielded cable and a shielded jack, you've got the shield locator, which is another TDR. All three of those are TDR functions. And in this case, what we're looking at, the bottom of this plot is a typical, what we call a pulse type TDR or an impulse TDR. And it's the TDR trace most people are used to seeing. And we see a spike at each end. That's just the jack at each end that we're looking at there. And then up top is what we call a step TDR. Now, step TDR can detect more minute changes in the cabling. In this case, we're looking at the shield. And what we're looking at here is the impedance of the shield. So in a pulse TDR, you'll see that spike from that change, but then it just flattens right back out all the way across until we get to the other end. In a step TDR, what we're seeing here is a change in impedance. It jumps up, and then as it goes along the cable, it just gives a slow rise. Now, this isn't a very big jump in impedance, but we're looking at two plots here. The one that I'm looking at here in blue from left to right is being done from our main unit. And then the other one right here, the black trace here, is being done from the remote. So we do it from both ends. We can also view this trace in both ends. I can, on my remote, hit the details, and then I can scroll down on my remote unit, and I can go into Shield Locator, and I can view that same trace that we're looking at. It's kind of hard to see, but there you go. So that's that same trace we're looking at. It's just flipped on this end so that it's relative to your position along that link under test. And then you can save this. And these details are also available in the PC software. So when you save this, when you've got these traces, these TDR traces for the shield and crosstalk and return loss, you can view them in the PC software when you're managing your test results as well. So in that case, that was a fairly normal looking cable. But I want to go ahead and connect to a different cable here to give you an idea. We'll just hit the home button on both of these, get them right back to our home screen. And we're going to connect to another cable with an intentional shield issue. And in here, in this case, we see we've got a good wire map. Everything looks like it's going to be fine. I'm going to go ahead and run an auto test. And in 6 seconds, we'll get our results, and we'll be able to take a look at this. And in this case, this cable failed. It failed several things. We've got a resistance problem. We've got a crosstalk problem. We've got return loss issues. We've got power sum next. Now, some of these are related to the shielding issue that I'm going to show you. Some of these are related to just other issues with this cable. There's something going on with the cable. If I click on the wire map button now, look right here. We see an indicator, a little sine wave showing 43.8 meters from the main and 44.7 from the remote, about halfway along this 95-foot piece of cable here. So we've got an issue with the shield. So I'm going to go into details, and we're going to take a look at the details here. So we look at DC resistance. Yeah, we know we got a problem there. One of the pairs actually has some really high resistance in this case, and we can look at that. So we see, yeah, 28 ohms. That's really bad. And you can see here we did run the DC resistance unbalance on that test as well. We can look at return loss. We failed return loss. We can look at our plots, but we know the plots are going to be bad. They're going to fail. So let's scroll down to the bottom where we have our return loss locator we talked about. We see a big return loss spike about midway through the cable. That wire map indicated that our issue was midway through the cable. Crosstalk, same thing. Holy cow, look at that. We've got a really big crosstalk spike about halfway through the cable. There's something going on with this cable. Let's look at the shield locator. Now, this is a very different trace from what we looked at before. We can see here on this pulse TDR trace at the bottom, we can see, and if we move this cursor in, we can zoom in on this. If we get right out here, we are actually right out getting close to that halfway point. So, we're looking at this, we're about 43 feet, and then we continue on, and this goes all the way out to right about 52 feet. So we've got a section of cable here, a few feet in length. where we have, it's probably about 7 feet in length, where we've got an issue with that shield. Now I'm going to zoom back out. We can see these step TDR traces as well. Now these actually give us a little more detail because they jump up and then come back down, and they're a little more accurate in the details. And these will find very small details. So if you notice, the detail doesn't, the spike doesn't look very big here at this midpoint on the pulse TDR. It looks bigger on the step TDR because it's designed to detect smaller issues. What is happening with this particular cable, and I can do the same thing on my remote. I'll show you, we can pull that result up. What's happening with this cable is that the shield was compromised. There's something done to this cable. And what it actually was done was it was cut and then spliced together. And it wasn't done very well. And the shield has a continuity issue as well, where the cabling, this was actually spliced through a mini patch panel where it was punched down on one side, punched down on another, and a short patch cord done between them. But the shield was actually touching just a little bit. It was compromised, but it was touching just a little bit. So on that initial wire map, we had a black line that shows that shield continuity, which addresses, there was a third question, Jacqueline, isn't a wire map test showing my shield is connected good enough? This is a good example of why that's not the case. If your tester doesn't give you shield integrity information, it's only giving you wire map, it's not going to help you for shielded cabling when you have issues like this, because it will show a good shield on a cable like this that doesn't have a good shield. And in this case, there's only just a tiny bit of braid touching that's making contact that shows that DC continuity for that shield. So that's what we're seeing here. And I can look at this, I can select the plot. So if I go in here, if I only want to look at Locator, that's going to be my little pulse trace at the bottom. And that makes that pulse a little bigger. If I want to go back in and let's say I only want to look at the trace coming from the main, which is our step, we get a much bigger image of that step trace, so we can actually get a better picture of what's going on there. And this will give you an idea of what's happening with the cable. Other things that you might see, and I'm going to go ahead and save this. So other things that you might see, and we'll go back to one of the ones that we saved a moment ago, and take a look at that test. And one of the things that you can also see, even though this cable passes, we can see a difference in the shields. So if I go back to that shield locator and we take a look at that, we're going to see right here where we got this shift. This shift happens right out at about the end of that patch cord that I was using. So if we jump out there, we see that we're right out near the end of the patch cord that I was using to test it. And that's a change in the shield. So the shielding of the cabling, in this case, has a slightly different construction than the shielding that we've got in the patch cord. So that's why we're seeing that little bump there, that little difference. That is just the difference in the shielding in the patch cord. You'll see this if you're using permanent link, if you're doing a permanent link test on shielded cabling as well. Your permanent link adapters are going to have a very, very highly shielded cable, with all the pair shielded and overall shields to give you the best possible construction. The cabling you're testing may be a little different, so you might see that in a test. Now, one of the things that you can see in a test like that, one that passed, this one, the anomaly wasn't enough to show it, but if we had one where the difference was enough, you would get the little sine wave indicators here that there's something changed in the shield right out at about that patch cable, like 2 meters roughly, if that's the length of your cord. And in the PC software, you have the ability to turn that on and off in the report. If it's not something that's causing your cabling to fail, but it's just alerting you that, yeah, there's a shield change, for your printed test reports, you'll turn that function off so you don't see the little sine wave in there. So it's not confusing for people. You can just turn that off. But it will show up if you want to show that in your shielding. Like if you're presenting, you've done an analysis for a customer on their shielded cables and there are problems and you want to show them those problems, you can do that with the PC software and show these anomalies, not just on the printed reports, but in the detail screens on that software. So if I import these tests, I can pull up my PC software here And I'm just going to go right in here. I'm going to open an existing project, and I'm going to import tests from my device. So I'm going to pull them in from my tester, and then I'll go to that project that we were just testing in, and I'll show you those tests that we just ran. We mentioned that we can look at the those plots in our trace here. I can go into the detail screen, and I'm going to pull this up. It always brings it over onto the other monitor. So here we go, and we can see, yeah, we've had some issues. We see all of our issues here, all these things that we failed. Let's go into that shield locator, and here we go. We see that shield locator, and just like with our tester where I showed you we can turn different things on and off, I can turn off the shield locator and turn off the remote and just show the main if I wanted to see that. And then I can show my marker, and I can scroll to where the event is, and it will show me how far out on that cable that event happens to be. So that's the benefit of being able to do that in your software as well. So I'm going to stop sharing my screen now, and we'll go back and see as we're getting close to the bottom of the hour here. See if we have any questions. All right. Matthias Korn, just sitting at the lake after work, 34 degrees, trying to follow the meeting. Great. He doesn't have a good connection, though. Is there a share video of the meeting to watch again? Yes. This will be available on demand. You'll be able to go to our website, and you'll be able to watch any of our past episodes. So this is episode 53. You can watch all 53. If you want to binge while you're out there by the lake, you can go ahead and do that. Somebody said, can I use shielded patch cords for an unshielded link? Yes, you can use shielded patch cords for an unshielded link. Technically, you probably want to keep the same all the way through, but you could use shielded patch cords. Now, here's something to keep in mind. Your equipment is shielded and it's grounded. So when you're plugging into equipment, you're plugging a shielded patch cord into that equipment. Now, that other end of that shielded patch cord, the other end of that shield has nothing to bond to. So you could end up creating an antenna situation, just like we talked about with not using a shielded patch cord in a shielded system, where you leave that telecommunications outlet end open. So you could create an antenna situation like that. If you're using shielded cords and it's unshielded cabling, you start to see you've got some noise issues, you might want to investigate that, and you can experiment with it. So let's see. Don't see any other questions. A few other people said hello. Like to thank everybody for jumping on with us today. Hopefully you got some good information out of this. I know sometimes shielding and bonding and those kind of things can be a bit mysterious. Here in the U.S. especially, a lot of people aren't doing shielded cabling, but it's starting to become more popular. I know in Europe it's always been shielded as far as I know. So pretty much everything over there, this is old hat for the folks over there. So I'd like to thank you again for joining us this time. And we are going to actually take a break for the month of July. We're going to take a break from Tech Talk, but we will be back in August. So stay tuned. Jacqueline is going to have some exciting posts about some changes we've got coming to Tech Talk, and we'll be back in August. So thanks everybody. Have a great day.